Welcome back. We are still on the topic graph of quadratic functions. In the previous video, we learned how to use the graph of a quadratic function to find the solution of the equation formed by equating the quadratic function to a linear function. In this video, we are going to learn how to use the graph of a quadratic function to find the solution of another quadratic equation. Finding the solution of another quadratic equation. We have already learned how to use the graph of a quadratic function to find the solution of the quadratic equation formed by equating the function to 0. So for example, if we draw the graph of the quadratic function y is equal to x squared plus x minus 6 on the graph sheet, and we have something like this. So we have the x-axis here, we have the y-axis here, and we have the graph of the function y is equal to x squared plus x minus 6. We have learned how to use this graph to find the solution of the equation x squared plus x minus 6 is equal to 0. As we can see, we got this quadratic equation by equating the quadratic function here to 0. And so, the quadratic expression in the function, which is x squared plus x minus 6, is the same as the quadratic expression in the equation, which is x squared plus x minus 6. We have learned that if you have this quadratic equation, the solution of the equation are the x-intercepts on the graph sheet. So the x-coordinates are the point where the curve intersects the x-axis. So the x-coordinate at this point and the x-coordinate at this point will be the solution of this equation. We have already learned how to do this in the previous videos. Now, what if after drawing the graph of the quadratic function y is equal to x squared plus x minus 6, we are asked to use the graph to find the solution of the quadratic equation x squared plus 8x minus 7 is equal to 0. Notice something here. You can see that in the previous example that we had, the quadratic equation was x squared plus x minus 6 is equal to 0. And we got that equation by equating the function to 0. And so, the quadratic expression in the equation was the same as the quadratic expression in the function. Now, in this example, the quadratic expression, the function we have drawn on the graph sheet is x squared plus x minus 6. And the quadratic expression in the equation is x squared plus 8x minus 7. They are different. So you can see that we did not get this quadratic equation by equating the function to 0. This is a different quadratic equation. How do we use the graph to find the solution of such a quadratic equation? Let's learn how to do it. To find the solution of such an equation, the first thing you have to do is to compare the coefficient of the quadratic term in the function to the coefficient of the quadratic term in the equation. We have learned about quadratic term in the videos on algebra. Also, in the video on Introduction to Quadratic Functions, we learned about the quadratic term. We said that the quadratic term is the squared term, that is the term with a square. So, in the quadratic function we have here, the quadratic term is x squared. In the quadratic equation we have here, the quadratic term is x squared. We are saying that to use the graph of this function to find the solution of this equation x squared plus 8x minus 7 is equal to 0, the first thing you have to do is to compare the coefficient of the quadratic term in the function to the coefficient of the quadratic term in the equation. As we can see from here, there is no number attached to x squared here, so it means that the number attached to it is 1. We learned this in algebra. In the same way, there is no number attached to this x squared term, so it means that the number attached to it is 1. So as we can see, the coefficient of the quadratic term in the function is 1, and the coefficient of the quadratic term in the equation is 1. So the coefficient of the quadratic term in both the function and the equation is 1. After we have compared the coefficient of the quadratic term in the equation to the coefficient of the quadratic term in the function, what do we do next? If they are the same, that is, if the coefficients are the same, subtract the equation from the function. So the next point says that after you have compared the coefficient of the quadratic term in the equation to the coefficient of the quadratic term in the function, if they are the same, that is, if the coefficients are the same, subtract the equation from the function. As we can see here, the coefficient of the quadratic term in the function and the coefficient of the quadratic term in the equation are both 1. So it means that they are the same. The point here is telling us that if the coefficients are the same, then subtract the equation from the function. So here, because they are the same, we are going to subtract this equation, s squared plus 8s minus 7 is equal to 0, from the function that we have drawn on the graph sheet, which is y is equal to s squared plus x minus 6. So we are going to subtract this equation from this function. I'm going to take the graph off so that we can continue with the solution here. I'll first write the equation. So we have y is equal to s squared plus x minus 6. Because you are subtracting the equation from the function, I'll arrange the equation in the same way as the function. So here we have y is equal to s squared plus x minus 6. I'll bring the 0 on the left hand side, then I'll write the quadratic function on the right hand side. Now this is what I mean. I'll bring the 0 here, so we have 0 is equal to, then I'll write the quadratic function on the right hand side. So we have 0 is equal to s squared plus 8x minus 7. Remember that we have not changed anything. We have s squared plus 8x minus 7 is equal to 0. And here it is 0 is equal to s squared plus 8x minus 7. I just interchange the position of 0 and the quadratic function. Okay, so we can now go ahead with the subtraction. Remember that we are subtracting the equation from the function. So we are going to subtract the equation, which is 0 is equal to s squared plus 8x minus 7, from the function, which is y is equal to s squared plus 8x minus 6. So let's start. We will have y minus 0 is equal to s squared minus s squared plus x minus 8x minus 6 minus 7, and that will give us plus 7. So as you can see, we subtract the equation from the function. So we have y minus 0, s squared minus s squared plus x minus 8x, then minus 6 minus 7. S squared minus s squared will give us 0. So we can see that s squared and s squared will go away. So you will be left with y minus 0, which is y, x minus 8x. From algebra, we have learned that this will give us minus 7x, then minus 6 plus 7, which will give us positive 1. So after subtracting the equation from the function, we have y is equal to minus x plus 1, which is a linear function. Now, what do we do next? Draw the graph of the resulting linear function on the same graph sheet. So the point here is telling us that after we have subtracted the equation from the function, we are going to have a linear function. We have to draw the graph of that linear function on the same graph sheet as the quadratic function. The linear function we are having here is y is equal to minus 7x plus 1. So now to find the solution of the quadratic equation s squared plus 8x minus 7 is equal to 0, we have to draw the graph of the linear function y is equal to minus 7x plus 1 on the same graph sheet as y is equal to s squared plus x minus 6. We have already learned how to draw the graph of a linear function on a graph sheet. We have learned that to draw the graph of a linear function on a graph sheet, you will need at least 2 points that fall on the line. So you assume an x coordinate, you substitute it into the equation, then you get the corresponding y coordinate. You do the same thing to get another point. Then you plot those 2 points on the graph sheet and join them with a straight line to get the graph of the linear function. So let's say that after getting those 2 points and plotting them on this graph sheet, we have the first point here and we have the second point here. So you join these 2 points to get the graph of the linear function y is equal to minus 7x plus 1. Now at this point, we have both the graph of the linear function y is equal to minus 7x plus 1 and the graph of the quadratic function y is equal to x squared plus x minus 6 on the same graph sheet. How do we use this to find the solution of the quadratic equation x squared plus 8x minus 7 is equal to 0? The solution of the quadratic equation is the x coordinates of the point of intersection of the two graphs. So the solution of this quadratic equation x squared plus 8x minus 7 is equal to 0 is the x coordinates of the point of intersection of the two graphs. As we have seen, when we subtracted this quadratic equation from this quadratic function, we had this linear function. After drawing the graph of this linear function on the graph sheet, we can see that the straight line and the quadratic curve intersects at this point and this point. We are learning here that the solution of this quadratic equation, which is x squared plus 8x minus 7 is equal to 0, is the x coordinates of the point of intersection of the two graphs. So the x coordinates of the point of intersection of the straight line and the quadratic curve will give us the solution of this quadratic equation. So the first point of intersection is here and the second point of intersection is here. To get the first solution of this equation, we will trace the first point of intersection to the x-axis. And to get the second solution of this equation, we will trace the second point of intersection to the x-axis. Let's say that the value here is x1 and the value here is x2. So the solution of this quadratic equation will be x1 and x2, which are the x coordinates of the points of intersection of the straight line and the quadratic curve. This is how to find the solution of the quadratic equation when the coefficient of the quadratic term in the function and the coefficient of the quadratic term in the equation are the same. We have learned that if the coefficient of the quadratic term in the function and the coefficient of the quadratic term in the equation are the same, like the one we have here, you will subtract the equation from the function. After that, you will get a linear function. In our case, we had y is equal to minus 7x plus 1. You then draw the graph of that linear function on the same graph sheet as the quadratic function. You will see that the graph of the linear function, which is a straight line, will intersect the graph of the quadratic function, which is a curve. The solution of the equation are the x coordinates of the points of intersection of the straight line and the quadratic curve. Now, how do we use the graph of a quadratic function to find the solution of a quadratic equation when the coefficient of the quadratic term in the function is different from the coefficient of the quadratic term in the equation? We are going to learn how to do that in the next video. So see you in the next video and let's continue with the solution. Bye bye.